Thanks a lot for the opportunity to give a talk. I'm from the Linz Center of Mechatronics. I'm working there as some kind of technology scout. I'm investigating future technologies and see or make it up what kind of impact they might have on other disciplines or industries. I've structured my talk into 3 parts and it would take a miracle if we will make it through to part 3 because of the lack of time, so I'll try to hurry up a little bit. First part is blockchain in an extremely tiny nutshell. I don't know who of you has already heard of blockchain, but I'm sure that every one of you has heard about bitcoins. And blockchain is the technology that enables bitcoins and all other cryptocurrencies that are out there, and daily added new cryptocurrencies to this pool of cryptocurrencies. I want to start with some kind of definition. A blockchain is a continuously growing list of records called blocks, which are linked and secured using cryptography. So I'll let this sentence settle a little bit. This blockchain, this database has now the property that it's present all around the globe. So the first feature of the blockchain is that this database, you have a reliable consensus that every user on the planet holds an identical copy of this database, whatever you use it for. All the entries in this database are non-deletable, so you can only add things, you cannot change them, and you cannot delete them. Everyone on the planet knows who made the changes or the amendments, the things that are added, and everyone knows when they have been added. All these addings are completely auditable, so you know who did it, and there's no possibility that I'm pretending that someone else did the change. It's clear that I did the change. The whole system is controlled by a community, so it's not possible that any government or a single company is manipulating the results in their interest. So you need more than 50% of the global community to make changes to the system. So it theoretically could not be corrupted. And this brings another side effect with it. There's no hotline. So you cannot call anyone to tell them you have made a mistake and they should please undo it. If millions of bitcoins and euros and dollars are lost by this effect. The first application is accounting. You know this application from the bitcoins. This is now the Bitcoin blockchain that we are talking about. And the Bitcoin blockchain solves an allegedly very old problem, a problem in accounting, that you have 2 options and neither of them is good. Up to now you could have make your bookkeeping in a centralized ledger, so the bank is the only one who keeps the records of all financial transactions and calculates the account balances in the end. And this needs you to trust the bank, and you don't know if you want to do this. So all the people who distrust the bank could keep their individual ledger and keep records of all transactions that have ever taken place in the history and calculate their account balances on their own. But this leads to an important problem. If I'm talking to bookkeeper Red that I want to spend all my money and transfer it to company A, and tell at the nearly same time to bookkeeper Blue that I'm spending all my money to company B. Some minutes or hours or days or months later, they will recognize they have different versions. The books are not identical. Which one is now the valid book and which of the 2 companies has got my money? So the consensus is a big problem, and with the blockchain technology, this problem is solved. You have a distributed ledger which is all over the planet. Everyone has an identical copy, and there is no way that there are different versions circling around. It could be, but there are strong economical interests for everyone to join the versions and to only let one version live longer. So this was an invention by Satoshi Nakamoto in 2008, and about 1 year later the Bitcoin blockchain was implemented, and since then the Bitcoin system is running. Most technologies have some features that they are providing, and beneath the surface there is a hidden iceberg of infrastructure that is needed to provide these services. And in my work, I'm not so much interested in the infrastructure beneath. So the infrastructure for the blockchain is where all the mining is happening. The Chinese are building mining farms, and the whole world has sold out the GPUs because there's so many miners who need them. Hash difficulties, all those terms are part of the infrastructure, which is very interesting, and I like it, but it's not so important for our process. What is important for our process are the features that are provided. We have to understand them. And the feature that is provided by the blockchain in one sentence is that it's providing you to send data to the rest of the world, to publish data in an auditable way. This sounds very boring, but if you look at another invention, the internet, it's all about sending data from A to B. This sounds not very interesting either. But you all know, of course, what happened to the internet. It was invented in 1969. It was about sending data between 4 nodes. Not very interesting. In 1977, a little bit more interesting. And in 2005, and even more now, you all know that it has become the foundation, or one of the technological foundations of our society. So there is another iceberg, the iceberg of hidden applications at the point of the invention of a technology. And nobody knew in 1969 what would be possible with the internet, that we would someday have social media, global container tracking, or data-based business models. Nobody had a clue. And it could be that we are, with the blockchain technology, at a similar point in history. We know some features, everyone is playing around with it. Some applications are out there already. Bitcoin is, of course, the famous one, but there are many other applications that are yet to be discovered and that could be real game changers. And one of these changes has already been invented. We have witnessed a transition from these pure cryptocurrencies, where you store in your database only the financial transactions, A sends to B 100 euros and so on, to the next stage. Some very smart guys had the invention that you could use this database not for recording these transactions, but to keep source code, software scripts in this worldwide database, and also to execute these scripts in this worldwide system. And this is nothing less than a world computer. It's called the Ethereum virtual machine, because Ethereum is the blockchain, the name of the blockchain on which this system is running. And this computer is Turing complete. So everything that you can calculate with an algorithm, you can calculate it with this Ethereum virtual machine. It's extremely expensive, it's extremely slow. 1 megabyte there costs about 1,000 euros. But nonetheless, if you think that, the scripts are also called smart contracts, because simple rules and simple contracts are the first ideas that emerged, which you could do with this machine. So, for example, 2 guys or girls want to transfer money, and they're not sure if they want to do it in the future, so they need the decision of both of them to really transfer the money. So this would be a very simple smart contract. If A is okay with it and B is okay with it, we transfer the money. But of course it's Turing complete. You can do really complex stuff with it. So another example would be you can make an insurance contract with an insurance company, because you plan and organize great events, large events under free sky, and you're heavily depending on the weather. And if it's raining, you make 0 euros turnover, and if it's sunny, then you get 1 million euros turnover. So you could make a contract with the insurance company that says if it's raining on this and that day, you will transfer 500,000 euros to me, and if it's sunny, I give you the 500,000 euros from a turnover. So this example shows one restriction that we are witnessing in these two systems right now, and which we think has to be tackled to get to the next level. This is that you need physical data entering into this system. Here the system is only living in the information sphere, so you get bytes in and get bytes out, but somehow you need to make contact with the physical world. And there are already concepts named, like the hardware oracles. These are things, sensor equipment, that tries to stretch out the complete mathematical reliability that is allegedly there in the blockchain to the last centimeters of hardware, where it's becoming dirty and physical, and you open doors for forgery. So these things are called hardware oracles because you get information from them, like from an oracle. I have made up the name for the thing that works vice versa. You might also need hardware Heracleses. Heracles was a guy who the guards were allowed to, or one guard, to give him an order. And you also need actuators that are reliable, performing the tasks that they are ordered to by the blockchain sphere. And speaking about sensors, speaking about actuators, this really sounds like mechatronics. And this is the reason why we are investigating this subject on a technological layer. We are situated 100 meters over there, a competence center also owned by the JKU. And we are doing lots of digital enabling technologies. And of course we do sensors and communication and actuators, so we're interested in the blockchain technology because we think it impacts us on a technological layer. But all these digital technologies have the characteristics that you end up pretty soon in talking not about only technologies, but if you do it with companies, you also end up talking about corporate strategy because it affects their business models or can affect them. So we had another format of projects implemented. We started 2 years ago. This is a picture from the final presenting of the results last year. And it's called open-foresight. We want to anticipate future developments, and we cannot do it alone. We need heterogeneous expertise. And so we invite decision makers from industry. We invite who are experts on their business. We invite experts, for example, with the project now on the blockchain. And I am expert in neither of these topics, but I try to understand as much as needed and possible to be a translator, to bring together the right persons and to translate the terms from the blockchain blockchain community into the terms that a businessman from a certain industry can understand, or a businesswoman. We want to keep a binocular view on this, so we are not only doing and organizing this project with the technological expertise, but we also are working very closely together with the JKU Institute of Strategic Management with Professor Regine Gattringer. She is a real expert on this open-foresight approach. She has made her habilitation on this topic. And we're closely working together, and it was great fun the last time, and now in October we are starting the next open-foresight project on the blockchain with companies like voestalpine, Greiner, Engel, Fabersoft and Atos, a worldwide software company. Thanks a lot.